In this video, you will learn the factoring pattern for quadratic trinomials in the format x squared plus bx plus c when c is positive. Now all of that probably sounds really confusing, but here is what we mean. So factoring is the opposite of distributing, right? So if you had x plus 2 times x plus 5 and you were to distribute, you would get x squared plus 7x plus 10. And in case you don't know how to get that, you would take x times x to get x squared, and then x times 5 to get 5x. So you have x squared plus 5x, and then distribute the 2. 2 times x is 2x, and then 2 times 5 is going to be 10. Alright, so you combine the like terms, 5x plus 2x, and that gives me 7x. So our objective in this lesson is to go backwards. So how to factor, which would mean how to go from x squared plus 7x plus 10 back into this x plus 2 times x plus 5 format. So we're doing the opposite of distributing. But to do that, we need to understand the pattern between the numbers x squared, 7x, and 10 with the numbers x plus 2 and x plus 5. Alright, so look at the 7. How can we get 7 from the numbers over here? Well, the 7 can be found by adding the 2 and the 5 together. Alright, so that is the pattern for this middle term. We add the 2 and 5. Now the question is, how do we get this last number of 10? Well, this last number comes from multiplying 2 times 5. So that's the pattern. If the number here is a 1 in the front, it's like 1x squared, we know the first expressions, the first terms has to be x. So x and x. So the question for this lesson comes down to what numbers go second. So here it's 2 and 5, but then, with other situations, what numbers would have to go there? So let's again look at the pattern with another example. Here we have x minus 3 times x minus 7. So once again, this middle number right here, this negative 10, you find by taking the sum of negative 3 and negative 7. If I add those two numbers together, negative 3 and negative 7, I get negative 10 for this middle term. And then the 21 comes from multiplying the negative 3 and negative 7. And that gives me a positive 21. So that is the pattern. So now we're going to get practice going the other way. So given, the x squared plus 7x plus 10, for example, how do we go back to this? So here is an example to illustrate. We have x squared plus 11x plus 24. So we know that we need to have two numbers. So it's going to be x and then x, and then something goes here and here. So the question is, what goes there? Well, we need to find two numbers that would add to 11 and would multiply to get 24, because that was the pattern, right? We added to get the middle number, we multiplied to get this last number. So it's easier if you look at the 24 first and you figure out what numbers multiply to get 24. So what are factors of 24? Well, I could have 1 times 24, and if I add those, I get 25. I could have 2 times 12, you add those to get 14. You could have 3 times 8 to get 24, you add those to get 11, or 4 times 6 to get 24, and you add them to get 10. Now the one I want is here in green, the 3 and the 8, because those would multiply to get 24, and they would add to get 11. So my numbers will be 3 and 8. So my factored form would be x plus 3 times x plus 8. Now for another example. Here we have y squared minus 13y plus 36. So I know to factor, I need to have two things in parentheses. And we have y and y. Then we have two numbers that go here and then here. So the question is, what two numbers go there? So to determine that, I'm going to look at the number 36. And I see what numbers multiply to get 36. And then when I find those numbers, I need to add them to get to a 13. Well, actually, negative 13. So the factors of 36, we could have 1 times 36, and those would add to get 37. Okay, that does not work because we need a 13 in the middle. 2 times 18 would be 36, but those add to get 20, which is not the correct number for the middle. 3 times 12 is 36, and those would add together to get 15, which is still not the middle term. We could do 4 times 9, which would be 36, and those would add to be 13. So this is the solution that I want. I want a 4 and a 9. And I could experiment with 6 and 6 and find that those add to get 12. But that's not necessary because we already have the 4 times 9. So we know it's going to be a 4 and a 9. Now the only thing is, notice this negative sign right here. It's a negative 13y. So I need a negative 4 and negative 9 because those would add to get negative 13. And they would multiply negative 4 times negative 9 to get positive 36. So my factored form would be y minus 4 times y minus 9. Now I'm going to finish this lesson with 3 more examples. First, we have x squared plus 13x plus 30. So once again, I know that this will factor to be x, and then a number here and here. So to figure out what numbers go there, I need to find two numbers that multiply to get 30 and add to get 13. So what numbers multiply to get 30? Well, I could have 1 times 30, and those would add to be 31, which is not the middle term that I need. I could do 2 times 15, which would add to be 17. I could do 3 times 10, which add to get 13. Or I could do 5 times 6, which would add together to get 11. The one I want is going to be the 3 and the 10, because 3 times 10 gives me 30, and they add to be 13, which is that middle number. So this will be a 3, this will be a 10, and they're both positive because we need a positive 13. So a positive 3 plus a positive 10 give me a positive 13. Next we have y squared minus 21y plus 20. So here we know it's going to factor where I have a y and a y, and then something goes there and there. So the numbers I put here, I find by seeing what multiplies to get 20 and adds to get negative 21. So to do that, I begin by looking at the 20. And I ask, what are the factors of 20? So 20, I could have 1 times 20, and those would add to become 21. Could be 2 times 10, and those would add to get 12. Or it could be 4 times 5, which would add to be 9. So the question is, which set of these do I want? Well, I want the first set right here, the 1 and the 20, because 1 times 20 is 20, and then they add together to get 21. But notice this sign is negative, which means that I need a negative 1 and negative 20, because negative 1 plus negative 20 would be negative 21 for the middle term, and they would multiply to get a positive 20 for that last term. So y minus 1 times y minus 20 would be my factored form. And lastly, we have x squared plus 13x plus 20. So to factor, I know this will look like the following, with an x at the beginning, and then a number there, and a number here. So to figure out what numbers go there, I need to find two numbers that multiply to get 20 and add to get 13. So looking at the 20, what are factors of 20? Well, we could have 1 times 20, which would add to get 21, 2 times 10, which would add to get 12, and then 4 times 5, which would add to get 9. There's no other way to get 20 other than these three sets of numbers. But notice that none of these would give you 13 when I add them together, which means that this expression does not factor. So we can say that it doesn't factor. We can say that it is irreducible, or we can use the word prime, all three of which means that it does not factor. And that concludes our lesson for today. We will see you next time.